Okay, so in this video I'm looking at fractions starting off with decimals and percentages and then converting to the more conventional format of an integer over or divided by another integer. Okay, so what I'm going to write down to begin with is, I think, a percentage. Let's keep it fairly simple. So let's have 56%. Okay? Now 56% we can immediately rewrite, hopefully, as 0.56. Okay? So whenever I've got a percentage, I very often like to convert it to a decimal, and you can just express decimals in this, express percentages in this decimal form. It's useful for things like spreadsheets where you don't want to use a percentage sign. Okay, so what I'm going to do now is think about what we've got here. Well, what we haven't got is 0.56. This isn't 56 because anything to the right of the decimal point is, of course, tenths and hundredths and thousandths and so on and so forth. Okay? So rather than say 0.56, which is going to confuse us, let's erase that. It's better to say 0.56, and we can express that like this. It's 0.56 is 5 tenths plus 6 hundredths. So now what we need is a common denominator. So we are going to use 100ths. And in fact, it's always going to be the further away from the decimal point, that's going to be the fraction that's going to be the common denominator. Okay? So in this case it's hundredths, so I need to convert. So I've got 10 times 10 is 100, so it's 10 times 5 because I'm increasing that, and as I'm increasing that. So 10 times 10 is 100, 10 times 5, 50. So I've got 50 plus 6 equals 56 hundredths. Now I hope that's clear. Another way of doing it, and how people are often taught, is simply to look at that right hand column and say, well, that's the hundredths column, so it's going to be 56 hundredths. I don't like doing that. I don't like immediately saying that because, again, I want to avoid this term 56. This isn't a 50 and this isn't a 6. But now we do have 56 divided by 100, so 56 hundredths. And I'm going to now think about simplifying this fraction to get it into a smaller form. So, not literally smaller, of course, it will still be the same size, but to get these numbers down to make it simpler. So one way of doing it would be just to halve it and halve it again. But what I'm going to explore in this video is something called HCF, finding the highest common factor, which is very useful for fractions. Now there'll be a separate video on HCF and looking at highest common factor problems, but I just want to show you how useful it is when dealing with something like this. So I can very quickly just write 56 here and 100 here and use a factor tree to break this number down into its prime factors. So I'll show you what I mean. So 56 is 2 times 28. 28 is 2 times 14. And 14 is 2 times 7. Now you could do it in another way. You could do it using a ladder method. So you'd end up with, you'd do it like this. You'd write 56 and go down to here, 28. So it doesn't matter how you do it. It's exactly the same method, but you'll end up with these factors. Very quick, very easy to do, and useful, because what we now do, I'm just going to erase that that ladder technique. But what we can now do, once we've got our prime factors, is we can look at our hundredth here and break that down as well. So we've got 2, 50, 2, 25, and then 5, 5. Okay, so I hope you're used to breaking down numbers into their prime factors, and now you'll be able to see why that exercise was so useful, because here we've got a method to prevent us doing a whole string of breakdowns that we don't need to do. We can go immediately for the highest common factor, which is going to be 2 times 2. Okay, 2 times 2. Giving us 4. So we can say the HCF of 56 equals 4 times, well, whatever's left. We've got 14. And we can say the HCF of 100 is 4. Well, it's just, I shouldn't say equals because this is just the factors at the moment. Let's just erase that. So we've found the highest common factor is 4, so we're just rewriting these numbers. We've got 100 broken down now into 4 times 25. Okay, now this is a bit of a long-winded way of doing it. I would want to normally make a little shortcut so it's a bit faster. But what it tells us is that we can jump immediately to the lowest integer on the top and bottom in this way. So we've got 4 times 14 at the top here. We've got 4 times 25 at the bottom. We can cancel these 4s and get the answer 14/25. Okay, now nothing wrong with doing it the other way. For example, you could have simply said, well, equals 2 times 28 over 2 times 100, and you could then have said 28. What am I doing? Made a mistake. Okay, never mind. Let's just erase that. So 2 times 50, obviously, and then you've got 28 over 50, and then you could go on and break that down again in the same way to get 14/25. But this is a way of jumping straight to it, and it's quite a useful method, a bit like using the lowest common multiple when we're looking at the lowest common denominator. Alright, let's try another one. Let's look at something like 144%, which of course is 0. No, it's not. Let's erase my mistake, which is 1.44. Okay, so again, very important to get used to seeing percentages as decimals, saves an awful lot of time. So 1.44 is clearly 144 hundredths, so we could write it like that, 144 hundredths. I'm going to use another method though, and think about this separately. So I'm going to separate it up so that I've got 1, which would be 100 hundredths. I'll just write it like that for the moment, plus 44 hundredths. Now you see why in a minute I've broken it down like that, but what it does, I suppose, immediately is give us a slightly simpler number at the top here, and that's what we're going to break down. Okay, so let's go back to our HCF method and see if we can break that down nice and easily. So we've got 44 and 100, and we'll use factor tree. We'll go 2, 22, 2, 11, and we can't go any further. So now we're going to go 2, 50, 2, 25, and 5. Whoops. Okay, lots of mistakes in this video. 5, 5. And, which is exactly what we had here. But the factors might be different, so let's have a look. But no, we've also got 2 times 2 here and here. So we're going to say, and I'm going to not write it out here, I'm going to jump straight to it. 100 divided by 100 plus 4 times 11 gives us our 44, and 4 times 25 to give us our 100. That gives us then 100 divided by 100. I'm going to say 1, and we can cancel these 4's, so we've now got 11/25. So I hope I didn't jump too many steps there, but hopefully if you pause the video, rewind it, have a look at this carefully, you can see how we can quite quickly go to an answer here. If we don't like this as a mixed number, then of course we can just multiply out. So we've got 25 times, we've got 25 25ths, so we can just say that's 25 over 25 plus 11/25 gives us 36/25. Okay, so that's our answer to this one. Let's try another. 0.365. Now I don't know what that's going to give us, but I do know it's going to give us a fraction. If you have a decimal, there are some very famous ones, things like pi, where the numbers go on forever and there's no pattern, there's no recurring pattern, then you're not going to get a fraction. So that's an exception. But with most things, you're going to see an end to this decimal somewhere or a recurring pattern, and then you know you can convert to a fraction. So let's have a go. We've got 365, so we can write 365 divided by 1/1000. It's very easy to write 1/100th, so if you're not sure, just count it out. We've got tenths, hundredths and thousandths. Okay? Or you could do the long method of writing, breaking it up and writing it out, and then finding the common denominator. Okay? But the common denominator is 1,000th, so I've skipped that step, and now let's go to the next step. So what we're going to do is think about HCF again. We've got 365 and 1,000, so we can break that up. And if I look at this, I can immediately see that I've got 5. Okay. Now I've got a little division problem. I've got 5 into 365. Now normally I think I'd write this out, but for the purpose of this video I think I'll just do it directly. So it's pretty much written out in bus stop form. So 5 into 36, I'm going to do it like long division. So 5 into 36 gives me 7. So I'll write my 7 here. 7 times 5, 35, so carry 1 to get 15. And 5 into 15 goes 3. Okay. So we've got 5 as one of the factors, and over here we've got 73. I can't break 73 down any further because I can see that that's a prime number. Now if you can't see that that's a prime number straight away, you need to try and break it down and see, get as far as you can. So divide by 2, no, that won't work. Divide by 3, divide by 5, divide by 7, even go as far as 13, maybe 17. But eventually you should be able to work out that that's a prime number, and so it's not divisible any further. Okay, so now we've got our thousandths here. We're going to divide that into 2 and 500. And we can see immediately that we've got a 5 here and 100. Now I can break that down as well. I'll just do 3 dots to represent that. But all I'm looking for is the same factor as I've got here. I know I'm not going to get 73, but I am going to get a 5. So there's my 5. And so my HCF is 5. And now I can rewrite this. So I can say that's 5 times 73 divided by 5 times 200. Okay, check back. 5 times 200 is 1,000. 5 times 73 is 365. So I can now cancel my 5s and end up with my answer, 73 over 200. Okay, let's do just one more. Let's pick something. So let's have an improper fraction. So again, as a decimal, this will be greater than 1, so it's 4 point, let's keep the numbers fairly simple, 288. Okay? So I don't know how that's going to break down, but let's give it a go. So 4.288, well, I could start with thousandths, but for the same reason that I had before, I'm going to say 4,000 divided by 4,000. That will start me off. I could just write 4, but I do prefer to write it out in full so that I can see what's going on. Okay, so now I've got 288 and 4,000 here. Sorry, what am I doing? Let's erase that. Another mistake. So I've got 1 thousandths. So I've got 4 thousandths and 288 thousandths. So just made a little slip there. It's not a worry. It's not a problem if you make a mistake. We all make mistakes, and that's why I'm keeping them in these videos. The important thing is that you understand what you're doing, then you'll see your mistake and you can check as you're going along that it all sounds reasonable. 4,000 divided by 1,000, that is 4. So I'm going back and checking, and now I realise what I did wrong and why I made that mistake. Okay, so we need to break this one down. This one's okay. We need to break this one down. In fact, I can immediately, let's just do this. I wouldn't normally do this, but let's just cancel those zeros there so we can see that's 4 divided by 1, 4. Let's go for this one anyway. Now what we've got is 288. Let's do an HCF on this. 288 and 1,000. I've already done 1,000 here, so I can begin to see what's going to happen with that. Let's do the 288. Well, we've got a prime factor of 2, obviously. We've now got 144. This is going to break down quite a lot by the looks of it. 272. Okay, this is fun. 236. 218. 2,9, and now 3. So with 288, I've got a really interesting HCF. I'm going to say the let's just say the factors of 288 are 2, 1, 2, 3, 4, 5. So I'm just going to write this 2 to the power 5 times 3 to the power 2, in other words 3 squared. So that's got my factors sorted out. I'm now going to look at this 1,000. Well, I know I'm going to get 2. I could start with 5, but no, let's start with 2. So I'm going to get 2 and then 500. I'm going to get 2 again and 250. Now I can't get 2 anymore. I've got, well, I can divide it by 10, so I can divide it by 5. So I'm going to get 550, 5 again. Well, I could divide that by 2, couldn't I? So 225, doesn't matter what order you do it in, and I've got 5, 5. So there's my unique prime factorization. And now I'm looking for common, my highest common factor. So I'm going to ignore the 5s because I've got no 5s here. I've got 2 2s here and another 2 here. So I've got 2 times 2 times 2. So I've got 2 cubed. So here that's going to be 2 cubed times 2 squared times 3 squared. So I'm just expressing this in a slightly different way. This one equals 2 cubed times 5 times 5 times 5, so that's 125. Okay, so I'm going to say that's 5 cubed. All right, if you're not familiar with indices, don't worry too much about this, but this is just a shorthand instead of writing out 2 times 2 times 2 times 2, and it's something that I'm quite familiar with using. You might want to practice. Okay, but we've got our prime factors now. We're ready to go back to this. So we can say that we've got, how many did we say here? We've got 2 cubed as our common, okay, 2 cubed here, and 2 cubed here as our highest common factor. So we can write that 2 cubed is 8, so we've got 8 times, now we've got 2 squared, that's 4, times 9, that's 36, so that's 36, and underneath we've got 8 times 125, 5 cubed is 125. So that was an interesting challenge, but it should have worked correctly. Like I say, we could easily, perhaps more easily, just divide this down, so I could have halved that and just done a whole string here, and I would have got down to the same answer. But I wanted to jump, so I've got 8 here that I can cancel, and I've ended up with 36 125ths, and I can be certain, because of the method I use here, that that won't cancel any further. So that's the answer. Now, I need to remember I have forgotten my 4. So in fact, what we've got here, I should just rewrite this. Okay. So let's just rewrite this. We've got equals 4 and 36 25ths equals 4 and 36 125ths. So now I could multiply that back out again, but it's such a large number, I think it's useful to keep it in this format. So my answer is 4 and 36 125ths. Okay. Okay, so just to finish off this video, let's just add a few notes about the highest common factor. What is the highest common factor? What does it really mean? And to illustrate that, what I'm going to do is, let's choose some simpler numbers now that will break down more easily. Let's choose just 20 and 30. Okay. So what we're trying to find to start with are the factors of 20 and the factors of 30. Then we'll find the highest common factor. So what are the factors of 20? Well, you're probably quite familiar with this. So it's harder to work out the multiples, but it's something you're probably quite practiced in. Let's have a go. So the first factor of 20 that we've got is 1. So 1 times 20, so we're going to end up with 20 at the end. Another factor would be 2, so 2 times 10. 4, so 4 times 5, so the next one's going to be 5, and then we've got 10 and 20. So these are the factors of 20, and although it's more difficult to list out than the multiples, which are our times tables basically, it should be something that you're fairly used to doing, and it's the background knowledge that you need to understand the more advanced methods that I was using in the first half of the video. Okay, now we've got the factors of 30, so we've got 1, 2, what have we got next? 3, 5, and now 5 6s are 30, so we've got 6, and 3 10s are 30, so we've got 10, 2 15s, and 1 30, 1 times 30. So those are the factors of 30, and those are the factors of 20. Now let's just change the colour here a minute. Let's use bright red. Okay, so what are the common factors? What are the common factors? So we've got a common factor of 1 here and 1 here. Okay, we've got another common factor of 2, so 2 is common to both these numbers. And well, 4 and 3 aren't common, so we now move on to 5 and 5 and 10 and 10, so 6 isn't common, 15 isn't common to both these numbers, 20 isn't common to both these numbers, and 30 isn't common either. Therefore the highest, let's go back to white. Okay, the highest common factor, the HCF, or if you're in the United States, the GCF, equals 10. So the HCF equals 10. Now, what we were doing in the video was breaking down the numbers into prime factorization. So I'm going to do that just to compare these two methods. So what we did was we took the 20, if that was the figure, and the 30, and we were saying, well, 2 times 10, 2 times 5, and then we're finished, 2 times 15, and 3 times 5. And you can see what this does. It gives us, well, we don't need this one, the 1. We know that 1 is common to every number because 1 is an identity number. And we do need 10, and we do need to find the 2's and the 5's. So we found the 2's here and here and just 1 here, and in that case the 2's are only we only have 1 2 that's common, so 2 is common just once, and that's why we only ring one of these like this, and the other common factor is 5, so let's just ring our 5 here. And so now we've got 2 times 5, 2 times 5, therefore HCF equals 10. The highest common factor is 10. So we're not doing anything different here really, it's just a different way to get at the same result. And you can see all the numbers that we got by listing them out are also achieved by this method. Okay, so I hope that's helpful. I hope that makes you think a bit more about HCF and how it's used, and understand a little better how we break things down using prime factorization.